To begin with, we're going to talk about how to look at an equation, look at a graph, and look at a table and be able to tell if it is an exponential function. Okay, so we're going to review how to look at a graph and how to look at an equation, and then the table part will be a little bit new. Okay, so if you're looking at a graph, so I'm going to move it so that you can see the graphs. If you're looking at a graph and you're trying to tell if it's exponential, remember exponential graphs can look one of two ways. It can kind of like this one, it could kind of start looking kind of leveled off like it does on this part, and then it's going to increase dramatically. And so if it kind of starts off leveled off on one part, and then as you go to the right of your graph, it goes up dramatically, that is an exponential function. So like notice this one does the same kind of thing. It's kind of leveled off at the beginning, but then all of a sudden it takes a turn and it starts to go up dramatically. So those, remember, are exponential growths. So they're exponential. The other way that an exponential graph could look is it could actually do the opposite. So it could start up kind of like this one does, and then it can decrease dramatically or all of a sudden, and then it'll kind of look leveled off on the right hand side. So either way it looks, those are all exponential graphs. Okay, so that's how you tell if it's exponential in the graph. Okay, and so this little reminder is there for you. So an exponential function is level or kind of flat looking on one side, and it's going to be very steep on the other. Okay. In the equation, remember exponential equations, the standard form is y equals a some number times b some other number to the x power. So looking at the equation, remember the big thing to be exponential is you're wanting the x to be in the exponent spot. So if you look at an equation and the x is in the exponent spot, then that would be an exponential function. Okay, so now what we haven't talked about yet is how to look at the table and know if it's exponential. Okay, so that's what we're going to spend the majority of this video talking about, is how to look at a table and how to know if it's exponential. Okay, so that's what this is talking about to begin with. It says a relation is exponential if the domain, which remember we talked about before, your domain is your x values. A relation is exponential if the domain or your x values are at a regular interval, meaning that they're increasing by the same amount each time, so that the intervals are equal. So your x values have to kind of increase or decrease by the same interval each time to go from one to the next. It has to follow the same pattern, in other words. And the other thing that has to happen is your range, which remember your range are your y values. Your y values have to actually multiply by what's called a common factor, which means the pattern between your y values is you are multiplying by the same number. Okay, so to have a common factor means that you're multiplying by the same number each time. So when you're looking at a table and you have to tell whether it's exponential or maybe it could be some other function, to know if it's exponential, you have to have this happening. So the two things you have to check is your x values have to increase or decrease by the same amount. So like if I was looking at this table right here, I'm going to start by looking at my x values, and I'm going to just make sure that they're increasing or decreasing by the same amount. So like to go from 0 to 1, 1 to 2, 2 to 3, 3 to 4, so on and so forth, you have to be adding or subtracting the same number. Okay, so like they have to be going up by the same amount. So like to go from 0 to 1, I'd have to add 1, and so I'd have to double check and make sure all of those, the rest of them, do the same thing. So like to go from 1 to 2, you are adding 1. To go from 2 to 3, you're adding 1. I don't know why. Oh, I guess it's because I said 3. You're adding 1. 3 to 4, you're adding 1. 4 to 5, same thing. And then 5 to 6. So that is happening. Your domain, your x values are at a regular interval, an equal interval, okay? And so if that's happening, then you're going to look at your y values, and you're going to make sure that your y values are actually multiplying by a common factor. So this is different than your x values, okay? So you start by making sure that your x values are kind of increasing by that regular interval, okay, or at a regular interval. Then, if that's happening, then you're going to look at your y values. And now, to be exponential, this is the part that makes them exponential, your y values have to have that common factor. In other words, you have to be multiplying by the same number to go from one y value to the next. So it does take some thought. So think about, like, what would I have to multiply 64 by to get 32? Okay, and so notice it decreases. So you're not multiplying by like a whole number. So think about, what would I multiply 64 by that would all of a sudden make it 32? And if you kind of think through it, you'll realize that if you essentially take 64 and divide it by 2, you'll get 32 out of it. So, well, then what number would that be that you're multiplying by then? That would mean that you're multiplying by 1/2. Because when you're dividing something by 2, that's actually the same thing as multiplying it by 1/2. Okay? So, to be exponential, the rest of these, to go from one y value to the next, you have to do the same thing. So that all we're going to do is just double check, and you have to check all of them. We're going to double check and make sure that you are multiplying by 1/2 all the way through. So like to go from 32 to 16, if we multiply by 1/2, or in other words, divide by 2, will that get you 16 out of it? Yep, because if I take 32 and I divide by 2, or multiply by 1/2, I get 16. 16 times 1/2 will give me 8, so we're good so far. 8 times 1/2 will give me 4. 4 times 1/2 will give me 2. And then 2 times 1/2 will give me 1. So, because my x's were increasing by that, I had a regular interval in there, and then my y values were increasing by the common factor, or being multiplied by a common factor, that means that this would be an exponential function. Okay? So, you would say, yes, it is exponential. For that reason. So we're going to practice a couple more, just so you have a couple more examples to go off of, and then we'll switch gears and start talking about how to write equations with these. Okay, so this is a little bit blurry, so I'm going to see if I can clear it up. All right, there we go. All right, so these next couple tables, well, what if we had to check to make sure that those were exponential? Start with your x values and make sure that they have an equal interval to go from one to the next. So in other words, you're increasing or decreasing by the same amount. So like to go from 2 to 4, what am I doing? Well, I'm adding 2. So we have to just double check and make sure that they're all increasing by 2. If they weren't, then what we'd have to do is find the missing numbers, because that's going to affect kind of when we are comparing them to see if it's exponential. Okay, so from 4 to 6, what am I doing? Well, I would be adding 2 again. 6 to 8, adding 2. 8 to 10, adding 2 to go from 8 to 10, and then 10 to 12, I'm adding 2. So we don't have to worry about missing a number, okay? And because the interval is the same going from x value to x value, okay? So now that that's the same, the other thing we have to check, this is the thing that kind of makes it exponential, is exponential functions, the y values have that common factor. So now I have to ask myself, am I taking the y values and multiplying by the same number as I go from one to the next? So you just have to find the pattern. So you would ask yourself, what do I multiply 1 by that would give me 4? Because that should be the same all the way across the board. So 1 times what gives me 4? Well, that shouldn't take much thought. If I multiply 1 by 4, I get 4. And so in order for it to be exponential, I would have to have that common factor all the way through. So all you're going to do is check to make sure that you're multiplying by 4 all the way through. So 4, if I take that times 4, will I get 16? And yes, I will. So I know that that one's good, but then you have to check the rest of them. So 16, if I take 16 times 4, will I get 64? And you could check it. You could take 16 times 4 if you didn't know what that is on your calculator, or by hand. Go to the side and do that by hand, and you would notice that that actually works as well. And then if I take 64 times 4, I would get 256, so that works. And then if I take 256 times 4, then I would get 1024. So because the x values had that regular interval and my y values had the common factor, this one would also be exponential. So this would, you would be able to write an exponential equation for, okay? So then the last one, same story. Check the x's, make sure they have the common interval or the regular interval to them. And then if that's the case, then you look at the y values and make sure that they are multiplied by that common factor to go from one to the next. So to go from 1 to 2, 2 to 3, 3 to 4, what's that interval? Well, they're going up by 1. So we're good there. So then double check and see if your y values have that common factor. So what do I multiply 3 by to get 9? That should be the same thing across the board. So if I take 3, well, if I take 3 times 3, it'll give me 9. So that should be the common thing, or if it's not, then it's not exponential, okay? So if I take 9 and I multiply it by 3, I should get 27, or it won't be exponential here. And so notice 9 times 3 does give me 27, so it's got a common factor so far. But then if I take 27 times 3 again, do I get 81? If yes, then it's exponential. If not, then it's not exponential. And notice if I take 27 times 3, I do get 81. And so, because they had that common factor and my x values had that equal interval, this one would also be exponential. Okay? So that is how to tell, just by looking at the table, if it's exponential. Your x value should have that equal interval, and then your y value should have the common factor.